Good day everyone, welcome to Senior Pablo TV. And for today's tutorial video, we will be discussing the introduction to hyperbola. Unlike the parabola and circle that you already discussed in your junior high school, this hyperbola is a new lesson to you, just like the ellipse. So it's a little bit tricky or hard for some, and of course you need to integrate your knowledge about the parabola. So let's have first a definition. A hyperbola. So let f sub 1 and f sub 2 be two distinct points. So our f sub 1 and f sub 2 are our foci. The set of all points, let's say P, whose distances from the f sub 1 and f sub 2 differ by a certain constant is called the hyperbola. So let's say we have here our graph, the graph of a hyperbola. So this is our f sub 1 and f sub 2. And let's say P is the point. So a point is consists of the x coordinate and y coordinate, or the abscissa and the ordinate. So their distance may differ through a certain point. And we have here the point of the f sub 1 minus point of the f sub 2 is equal to, I'll get their absolute value, the positive value, is equal to 2a. Okay, so this is the graph of the hyperbola. You will also encounter the following terms. An asymptote is a line that a curve approaches at its heads towards infinity. So in our graph, where is the asymptote here? It should be P here, asymptote. Okay, there must be P here. So our asymptote, it is a line, so this line. So we have two asymptotes, the first line and the second line. So our hyperbola, if we're going to extend, it will draw closer and closer to our asymptote, but they will never meet, or they will never touch each other. So notice that we have two lines. So the slope of this line is a positive, and the other line, this slope is negative. So in our examples, you will understand that asymptote. We also have the transverse axis, is the axis of hyperbola that passes through the 2 points. Transverse axis that passes through the 2 points, 2 foci. The conjugate axis is the axis of a hyperbola perpendicular to the transverse axis at a point equidistant from the focus. So notice that a conjugate axis is perpendicular to our transverse axis. So if our transverse axis is located here, so our conjugate axis is vertically. They are perpendicular. To better understand, let us now proceed to our first example in the next video. And we have our second example for the hyperbola. So y squared over 16 minus x squared over 20 is equal to 1. We're going to find the center, the foci, the vertices, equation of asymptotes, and the graph. So first, study the given. So the given equation is y squared over 16 minus x squared over 20 is equal to 1. So obviously, that is in the, so our center is 0, 0. And our equation in standard form is just like this one. So we're going to follow this step in our table. Okay. Now let us find the A, B, and C. For our A squared is equal to, this is our A, so that is 16. So get the square root. So our A is positive 4. And for our b squared is equal to 20. So extract the square root. B is equal to square root of 20. Now, 20 is not a perfect square number. So, B is equal to, get the factors of 20, that is 4 times 5. So, the one factor or the other factor must be a perfect square, which is 4 is a perfect square. So, B is equal to 2 square root of 5. Okay. This must be positive, negative 2 square root of 5, but since we are looking for the distance, so we're just going to get the positive 2. And for our C is equal to square root of 16 plus 20 square root of 36. 20 plus 16 is 36, so C is square root of 36 is 6. Okay, so A, B, and C. So you will notice that, sir, 2 square root of 5, that is in radical form. So get the decimal equivalent of that, that is approximately equivalent to 4.47, or near to 4.5. Just press in your calculator. Now, after getting the values for A, B, and C, we can now get the center, foci, vertices, and the equation of the asymptote. For our center, automatically, that is 0, 0. And for our f sub 1, it's here, so 0. Then negative c, our c is 6. For our f sub 2, 0. Then positive c, positive 6. Okay. Next, for the v1 or v sub 1, so we have 0, then negative a, our a is negative 4, then v sub 2, 0, then positive a, positive 4. Okay. Next, equation of the asymptote. So y is equal to, our equation is a over b. So we have a 4 over our b 2 square root of 5 then x. And for our graph, let us first locate the center. And the foci, 0, negative 6. 0, negative 6. 1, 2, 3, 4, 5, 6. So this will be our f sub 1. Then the second focus is 0, 6. 1, 2, 3, 4, 5, 6. Positive 6. This will be the second focus. And for the vertices, 0, negative 4. 0, negative 4. And for the second vertex is 0, positive 4. So second vertex and the first vertex. 4 and negative 4. Okay. Okay, we're now ready to draw our rectangle. So for our rectangle, A units away from C, A units. So A is 4, 1, 2, 3, 4, and 4. So this is our first line for the side of the rectangle. and okay, the second 9. Now, for the remaining sides of the rectangle, so B units. So that is 4.5. So 1, 2, 3, 4. This is 4 and 5. So between them, 4.47 between 4 and 5. Okay. Between 4 and 5. And of course, on the left side, between -4 and -5. So, okay. Now, connect for the graph or for our line, the equation of the asymptote, and the other one. So this is the center. Then this will be the positive negative. So y is equal to 4 over 2 square root of 5x, and the other one, y is equal to -4 over 2 square root of 5x. Square root of 5x. Okay. And for our graph, so this will be our graph. And the other one passes through the vertex. That's it. That will be our graph. Okay, let's go back in the equation of the asymptote. In your previous grade, when you were in grade 9, our restriction for the radical sign is there must be no radical sign in our denominator. So we need to conjugate. So we can write our equation of the asymptote. So if we have 4 square root over 2 square root of 5, we need to conjugate. We need to multiply that into 2 square root of 5 over 2 square root of 5. So this will become 4 times 2, 8 square root of 5 all over 2 times 2, 4 times square root of 5 times 5, 25. Now we have 8 square root of 5 over square root of 25, so 5 times 4, 20. Now reduce into lowest term. So this will become, or this is divisible by 4. So 4, 8, so 2 square root of 5 over 4, 8, 12, 16, 25. So the simplest form of our equation of the asymptote is, okay, let us rewrite, positive negative 2 square root of 5 over 5x. And this must be the positive 2 over 2 square root of 5 over 5x, and the negative -2 square root of 5 over 5x. Okay. Kindly recall your lesson simplifying radicals. You will be needing that in simplifying your final answer. So this is our second example for the hyperbola. See you in our third example. And for today's tutorial video, we will be discussing our example number 3 in the hyperbola. What if our center is not located in the origin, or our center is not 0, 0? So how are we going to find the center, the foci, the vertices, and how to graph the parabola? So if that is the case, we will be needing different table. So this will be the table that we are going to use. So notice in our graph, so this is not, or the center is not located in our origin. We know that our origin is located here. Okay. Notice that it is not located in the origin. So if our equation in standard form is like this one, so we have the hk for the center for this. So x minus h, quantity x minus h raised to 2 over a squared minus quantity y squared, y minus k raised to 2 over b squared is equal to 1. So this is our condition. Let a is greater than 0, b is greater than 0, and c is equal to square root of a squared plus b squared. So we have two cases. Equation is standard form. So in this case, where our parabola opens to the left or to the right, and in this case, open upward and downward. So notice that it's just interchange y that is in our a squared. Okay, just like in our first discussion, examples number 1 and 2, 0, 0, it also applied in that. Next, to find the foci, foci is c units to the left and right of c, if in this form. But in this case, c units above and below the x-axis. That's why in our graph, it opens to the left and opens upward and downward. So look at our rectangle. And for the vertices, a units to the left and the right of c, and in this case, a units above and below of c. Equation of the asymptote. So we have the asymptote here. So this will be the equation. Okay. Now let us use this table to solve this problem. Example number 3. So our given is quantity y plus 2 raised to 2 all over 25 minus quantity x minus 7 raised to 2 all over 9 is equal to 1. We're going to find the center, the foci, the vertices, the asymptote, and the graph. So first step, find A, B, and C. So our A here is, study the given. So y plus 2, so it is in this form. So we are going to expect a graph like this one. So a squared is equal to 25. So extract the square root. Our a is equal to 5. Next, our b squared is equal to 9. Extract the square root. B is equal to 3. And for the c is equal to square root of 25 plus 9. So that is square root of 34. Notice that 34 is not a perfect square number. So we're going to find the decimal of square root of 34. To find that, you can use the calculator. Square root of 34. That is, in decimal, 5.83. Or 5.83. This is our C now. Now, let us find the center. So, we're going to find the HK. So, the HK, so equate y plus 2 is equal to 0. So, our y is equal to negative 2. And the other one, x minus 7 is equal to 0, so our x is equal to 7. X and y, so our center is 7, negative 2. Okay. Now we are ready to find the foci and the vertices, and of course the equation of the asymptote. Let us find first our foci, the f sub 1 and f sub 2. So locate our center, 7, negative 2. So 7, then negative 2. So it's here. Okay, this is our center. Okay. Now, in our table, to find the foci, so this is our equation form. equation in standard form. So the foci is C units above and below of X. So our C is 5.83. So 5 units, 5.83 above. So we have into, so 1, 2, 3, 4, 5. 5, then again, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay, 5. In decimal, we have 0.83, so near 4. So it's here. So this is our f sub 2 or f sub 1. Let's say f sub 2 or f sub 1. Our coordinate now in our f sub 1 is, notice that the x is 7. And for the y, so how many units we have? 1, 2, 3. 3 units, and we have the 0.83. So 3.83. That will be the coordinates of the focus. The second focus or the first focus. Actually, we can name this as f sub 1. Okay. Next, 5.83 below. So below is 1, 2, 3, 4, 5. Then we have 0.83. It's here. So if we're going to find our f sub 2, the coordinates is on our x, we have 7. And on our y, so we have 1, 2, 3, 4, 5, 6, 7, negative 7 point, we have the decimal point 83. That will be our f sub 1 and f sub 2. We can now write in our answer 7, 3.83 and 7, negative 7.83. Actually, it can be interchanged. This would be our foci 2 or foci 1. It's okay, as long as your coordinates are correct. Next, the vertices. So for the vertices, that is A units above and A units below of X. Our A is 5. So let us count 5 units. 1, 2, 3, 4, 5. So it's on 3. So the coordinates of that, let's say this is our vertex 1. The coordinates is 7. And that is exactly 3. Okay. Let us write here 7, then 3. And the other one, 5 units below. So 1, 2, 3, 4, 5. So we sub 2, 7, then negative 7. So 7 and negative 7. Okay. Now, let us create our rectangle. So, just like in the first and second example, we're going to create a rectangle. That is, we have now our vertices. Then the second one is B units. Our B is 3. So 1, 2, 3. Then 1, 2, 3. This will be the rectangle. Okay, that will be our rectangle. Then we can now create our asymptote. Okay. So I think our rectangle is not proportion. So let us use our ruler. So drawing our vertex, then in this case, okay, then now if you're using a graphing paper, so it's easy for you to calibrate for the distances. But in my case, I am using the whiteboard, so it's a little bit hard. It's not proportion, so it must passes through our center. Okay, Gamma passes through the center, then 8 now a straight line, and for this one, passing through the center, and this one. Okay. And now, ready to graph for your hyperbola. Okay. This one. Looks like the hyperbola, our point. Where's our point? Here. No. Must be. So, like that. Okay. That is our hyperbola. And to find our asymptote, so that y minus our k is 7, k here, so minus negative 2 is equal to positive negative. Our a is 5 over our b is 3, and x minus h, our h is 7. Okay, so we have y, negative times negative, positive 2 is equal to positive negative 5 over 3, x minus 7. That would be the equation of our asymptote. So your teacher asks you to find the equation. So we have the slope of this is negative, positive. So we have y plus 2 is equal to 5 over 3, x minus 7. And in this case, the slope is negative. So the equation is y plus 2 is equal to negative 5 over 3, x minus 7. That will be our answers. And of course, the graph. That's it. That's the parabola. Your next example will be, what if the given is the foci and the distance of a point, the distance of our foci, the distance of the foci to the center, and given the vertices of the, or the coordinates of the foci. That will be your next lesson. Thank you for watching Senior Pablo TV. Welcome to our fourth example for the parabola. So let's have to solve the following problems in our board. Find the equation in the standard form of the hyperbola having the described features. Number 1, foci negative 3, 0 and 3, 0. And for any point in the parabola, its distances from the foci differ by 4. And the second question, vertices 5, 1 and 5, negative 5. And the focus is 5, 8. So if we're going to read that, it's a little bit tricky. Let's first solve the example number 1. Foci negative 3 and 0 and 3, 0. So if we are going back in our example number 1 and number 2, and examine in our foci in our table, notice that we have the coordinates, and our y are 0. So we know that the center for that is 0, 0. Okay. And in our introduction to hyperbola, we know that 2a is a distance of the parabola from the foci. So in this case, differ by 4. So 2a differ by 4, so is equal to 4. That is the distance. So to find the a, we need to divide by 2 by 2. So this will be cancelled out. So a is equal to 4 divided by 2. This is 2. This will be our a. So since we are, or the center is 0, 0, so we're expecting that our standard form can be x squared over a squared plus y squared over b squared is equal to 1. Okay, we are expecting this form, or it can be minus. Now, we have a value for a. What we need to do is find the value for c. And of course, the b. So let us find first the value of our c. So our c, so this is the center. We're going to find the c. Study the given again and look in your table in our example number 1 and number 2. The abscissa here is -3 and positive c. That means this is the distance of our c. So, since c is a distance, we're just going to get the positive, the length, the distance. Now we have values for a and c. Using our formula, c is equal to square root of a squared plus b squared. We're going to find b. So substitute. So c is 3 is equal to square root of a is 2 square plus b square. Now we need to remove the square root. To remove the square root, let us square our equation. So 3 square, that is 9. So square root will be cancelled out. The remaining is 2 square, 4 plus b square. Now, 9 minus 4 is equal to b squared. Addition property of equality, so we can move 4 to the left or add -4, -4. So 5 is equal to b squared. So to find b, extract the square root. b is equal to square root of 5. Okay, we are now ready to get the standard form. So we have x squared all over 2 squared minus y squared all over square root of 5, which is b, squared is equal to 1. So we have x squared over 2 squared, 4, minus y squared all over, so we cancelled out, 5 is equal to 1. And now our standard form. So in order for you to come up and solve properly this problem, you need to master first the introduction of our hyperbola. Of course, our table if our center is located in 0, 0 or in HK. Let us proceed with example number 2. The vertices 5, 1 and 5, negative 5 and focus 5, negative 8. So notice that our center is at HK. So to solve this, we can use or we can graph first. So let us graph first so that we can find the A, B, and C. Okay. 5, 1. 1, 2, 3, 4, 5, and 1. So it's here. This is let's say V vertex 1 and 5, negative 5. 5, then negative 1, negative 2, negative 3, negative 4, negative 5. So this is the vertex 2. Now we can locate the center. So the center is so 1, 2, 3. Negative 1, 2, 3, 4, 5. The center is located 1, 2, 3. So it's here. Okay. The center is located here because our center is, we have here A units from the vertex and A units from the vertex. The distance must be the same. So the coordinates of our center is 5, negative 2. This is our center. 5, negative 2. And from here, the distance is 3 units. 3 units. That is the A. A is equal to 3. Okay. Now we have now the values for the center and A. We also have a given of a focus. So from that, we can get the value of our C. So locate 5, negative 8. So we have here negative 1, 2, 3, 4, 5, 6, 7, 8. So it's here, negative 8. So from our center, that is the C. So 1, 2, 3, 4, 5, 6. So that is 6 units. So our C is equal to 6. Okay. Now we can get the standard form. Our standard form is written in, okay, you can check your notes for the standard form. So we have our standard form for the HK is Y. Our standard form is Y plus K raised to 2 all over A squared minus X minus H raised to 2 all over B squared is equal to 1. We need to find B. So to find B is the formula C is equal to square root of A squared plus B squared. So we have 3 squared plus, we're looking for B. We have value for C, which is 6. We need to remove the square root sign. So let us square. So 6 squared, 36 is equal to, this will be cancelled out, 9 plus 9B. Now, 36 minus 9 is equal to B squared. So we have 25 is equal to B squared. Get the square root, so our B is equal to 5. Now we can write in our standard form. So we have y minus our k is -2 squared all over our a is 3, so we need to square, minus x minus 5 raised to 2 all over 5 squared is equal to 1. So we have y plus 2 raised to 2 all over 9 minus x minus 5 raised to 2 all over 25 is equal to 1. This is now our standard form. Okay, let's rewrite. So y plus 2 raised to 2 all over 9 minus x minus 5 raised to 2 all over 25 is equal to 1. Okay, that would be the standard form of our parabola, hyperbola rather. Thank you for watching Senior Pablo TV.